hierarchical data structure which stores the information naturally in the form of hierarchy. Unlike linear data structures that we've covered recently, like linked lists and stacks and queues, trees are nonlinear. A tree is basically a collection of entities, and those entities are called nodes. Nodes are connected by edges, those lines. Each node contains a value of data. Now you can put any kind of data you want. Whatever node you create, it may or may not have a child. It's optional. Here we're going to be creating our program. Here we're going to create abstract data type and understand how the tree abstract data type works. So over here we have the class. So we have to create a class here. So I'm just going to create a class right here, and I'm going to call this as tree. Now the class will have a private section. So it has a private section, and it also has a public section. So in the private section, I'm going to create an internal class. I'm going to call this as tree node. And what the tree node is going to do is going to contain the members, the attributes, what a node consists of. So this is going to be specified as the public. So I'm going to go here as public. And what we could do here is the first thing is that string, and we're going to say data. So string data. This is our first data, and we're going to use a vector in this case, and we're going to put the tree node inside of it. Saying it's tree node, and we say pointer to tree node, and basically we put the children here. So the root nodes are going to be here. So just going to have to include #include vector here. So there you go. I included vector, and we have the tree node right in this place. Now after this, we could have something called a constructor. So once we create a tree node, we could have it say tree node, and inside that tree node we could have a string, and we could call that as D. Since we're going to add strings in this instead of integers, so we're going to have a data which is going to be a string, and the data over here is a string too, you could see. So I could use this, and I could say that data is equal to the D. And that's pretty much it for this, and I'm just gonna hit a semicolon here. Now what we could do is create a root, and this is basically another pointer. So tree node, and we can say pointer to tree node, and then we say root. So that's with our root, and we're pretty much done with that. Put a semicolon here, so just define the class here, tree. And let's just go out of this, and let's go a little further to see what we could create. So over here, actually, this didn't need any semicolon because actually it did. So this one this needed it, but this actually didn't need a semicolon. After the tree node, we have to add something else. Here in the public section, so we're done with the private section here. You can see this is private. So over here we're going to drop down and go in a public section. So I'm going to write here public, and what we could do here is create our constructor. So tree, it's called default constructor, and by default we could have tree root is equal to null. So by default it's null. And then we could have a destructor, so we say tilde tree and put that, and we could just implement anything ourselves. So I'll just leave this up to you. We could add anything yourself, so implement yourself. Right here we're going to create a show function of how we're going to show the children and all how the tree is going to work. So from here we're going to have a really important concept here to create this. So the thing you have to understand is that there's different types of traversals, and they're called tree traversals. And when we talk about tree traversal algorithms, they can be broadly categorized into two types. One are called depth first search, DFS, and then the other called breadth first search, which is BFS. Now, depth first search algorithms have three variants. So additionally, when we talk about breadth first search, there are going to be three different subtypes. One of the types is pre-order traversal, and then it's in-order traversal, and then there's post-order traversal. And then when we talk about the other one, which is breadth first search, BFS, it has just level order traversal. Now, I know this is a lot of information, and I can't really put all of it inside this video. Gonna make future videos related to these topics, but the thing that I'm gonna be trying to highlight here is that we're trying to use pre-order traversal, which is a part of DFS, which is depth first search. So how our tree is gonna be searching is that the tree is gonna go from here. We're gonna have a current node as the first. So whatever is like the root will be started, and that will be the first, and then it goes down to the left subtree. It will go left, and it will go until you see the bottom pit where you see the leaf nodes where there's no additional children. So here we go to the left subtree. After covering every node of the left subtree, we move forward towards the right subtree. So we get all the children of that left subtree, and then once we're done with that, we go to the next children of the root. So order of the steps will be like visit node, and then we go to the left subtree, and then we go to the right subtree. I'm going to use if statement, and here what I want to say is if the root not equal to the null, because in that case we could use it. Here we're going to have the condition. So we say stack, and we're going to have to use a stack here. So we're going to use a tree node, and we're going to say pointer to tree node, and we say s, which is the stack. Now what I have to do here is that I'll add the stack here. So hash include stack. Got the stack, and we're using the stack here, which is right here. So stack s right there, and then we're gonna be using a push statement, s.push, and we could push things into this stack using the root. You're gonna have to put a condition here if root not equal to null. Then we could basically traverse. So this is basically a show function, which is gonna show the traversal of the tree. So we have a stack, and we have a tree node pointer s. So we created a stack, and it stores all the tree node pointers. So it has the s as the identifier, and then we push the root into it. Okay, and then what we do is that we actually have a temporary null. So we say tree node, and then we have a pointer to the tree node. So I say pointer to the tree node with the asterisk, and we say temporary, and then we have a null. So null. And what we could do here is that we could put in a condition that how we're going to traverse is that if that is not empty, right? If the tree is not empty, what we could say is temporary is going to get from the top. So we could say s dot top, and right after this we could say that once we use it, we could just pop it out, because now it's stored in temporary, and we could just access it using console output. So we could say console output, and we could say temporary, so temporary, and the data we could just get, and then we could put let's just put an end line here. So I'm gonna put an end line, and then we could have the vector. So vector, and we're gonna create one which is gonna be for the children. So we could say tree node, and we know that it's a pointer to tree node, so we're gonna have to have that. And then we have this address of CLD. So this is gonna be referred for the children, and we could put that temporary, and we could put the children here. So say arrow children. So the temporary children are going to be pointed to this vector, and then we could have more things inside of this. So one thing that we have to include is the integer k. It's going to have the CLD, so CLD dot size function -1, and then we could have the while. So while k is greater than or equal to 0, so because we're going from k size, so it's going to be decrementing, we're going to have to push it out of our stack. So we say the children, and we're going to have that subscript of k, and we're going to push it out using, then we're going to have the decrement operator over here, and then we have this one, and then we have this one, which is, let's see, go over here. and it's this while loop, and then over here we have another while loop. I guess this is going to be the if statement, so this is all going to happen if it's null. And then we have the final one, which is this whole function, which is the show function. That's how our show function is going to work. Now let's have an add root function. So let's go downwards and create an add root function. So we say void, and we're going to say add root, and we're going to have a string d. And what we can do here is we can have if the root, so we have the root equals to the null. What we could do is say root is equal to new tree node. So we created a constructor using that, and we'll put that d inside of it, the value string d inside of it. Well, if that's not the case, well, we could have an exception in here. So else, put an exception. So I'll just leave that up to you. Put any exception you want. You use a try catch block. Right here we need a add child, so we're gonna say void add child, and it takes in a string, and it has a parent. So you want to add a child, but you have to associate what child is, which parent is it from. So we could create another tree node pointer. So tree node pointer to tree node, call it a temporary, have it inside a null, and then we have tree node, so tree node pointer to tree node, and we have parent pointer which points to the parent, have that as null as well. And then we create a stack just like we did with the other one, and again we have a tree node pointer, so tree node pointer, and this one will be called s as well. And then we could just keep on doing the same exact process here. So we just push the s, basically we push the root inside of it. So here we have to push the root, and then once we're done we could use a while condition, and we say the s is empty, so that while the s is not empty, you could have the temporary top, so s dot top, get the top, and then we're gonna have s dot pop to pop the first one, and then we're gonna have, because that's stored in temporary now, so we could say if the temporary, let's have a condition here. So if the temporary data equals to the parent, if that's the parent, right? So we find it, so we say parent pointer, and we just give it to the temporary, and then we just break out from this loop. Else we could just have, so we could have a for loop that's just gonna iterate through and try to find that parent. So we could just have a vector, and the vector will have a tree node, so I'm gonna have a tree node, and we're gonna have a pointer to tree node, so pointer to tree node, and we have a colon iterator, so that's gonna be the p, and it's just gonna iterate through. So pretty much it's just like how iterators work. So you go to the temporary children, and we're gonna have the beginning for this, so begin, and then we have the p not equal to, so we have temporary, and we have the children, so children, and we say dot end, and then we have the p incrementation, which is plus plus. Let's go in here and we basically push that thing inside. So push that, which is called the iterator, and we basically examine here if that thing is over there, so the pointer will just be assigned over there, pretty much like that. So after this for loop, we have this else block, and we have this else block terminated. So we have another one, which is basically this portion here, which is the while loop. After the while loop, we have one other condition that we have to test, and that is if the parent, So if the parent pointer is null, so if it's not null, so if the parent pointer is not null, if there's things inside of that parent pointer, so we could have the condition that we want to add the thing. So new, we'll say tree node, so tree node, and we'll have that D inside of it, so semicolon there, parent pointer, and we'll have the children, so we'll have, I would say the children, because we're adding a child, so children underscore children dot push underscore back function where you're going to be using, so children push underscore back of the stack, so we're going to have that temporary inside of it. And else, if the parent is null, we could have thrown an exception here. You could just like console output and say parent is null or something, whatever you want to do, it's up to you. I'm just gonna have an end line here. Let's have a child added, t.add child. So we're going to create a child, and we could just basically say programming fundamentals is a folder that's going to be contained in the D drive. So we're going to have that in the D drive, semicolon. Let's have t.add another child, and let's create this folder as, let's say, object-oriented programming. This is going to be inside of that D drive as well. So this is going to be inside of that. And then it's going to create more and more childs, but let's create some sub-childs to our course programming fundamentals. To that, we're going to have t.add child, and we're going to have additional child. So the additional child over here will be, let's say, quiz. So QUIZ. And we're going to have that belonging to the programming fundamentals. So we could just have that, something like that. Let's create another subfolder inside of that programming fundamentals. We could say this one as the project. So this is a project folder, and this is going to be inside the programming fundamentals folder. So we could have now another child, so belonging to this D drive. So we could have this let's say data structures and algorithms folder, pretty important folder. Over here we could have that in D drive, and there you go, semicolon right there, and we could just keep on adding again and again and again. So yeah, I hope that sums it up. Over here we're gonna have it show, so we're gonna have the show, and it's unformatted output. So it's basically an unformatted, it's just gonna appear as an unformatted output of a tree. And what I'm trying to say here is that you're gonna see that the thing is just gonna be in linear fashion, like this, in a line and line, because we're not gonna try to create a tree. Now that's a little, you need a graphic library for that. So we're gonna have to console output here and basically try to run this code. So hopefully after writing all of this entire code, we're gonna run this and see how this bad boy runs. I'm gonna go and type in G++, and I'm gonna say the file name. So my file was tree abstract data type, so tree abstract data type. Run the code, and I get a bunch of errors. So let's just go over here and see that there's some issue over here with that begin and end. Okay, I think I forgot adding the iterator header file. So let me, yep, I forgot to add the iterator header file. So let me just add that really quick. Hash include iterator, and let's just add one more that we used. No, so basically let's see what it reacts like now. So I'm just gonna have it run, and you get more errors. So there's some kind of issue here. We have candidate expect one argument, 0 provided. So we have begin, end, plus, and then there's, so in line number 90, let's just go line number 90 first. And in line number 90 we have, over here we have a for loop, we have vector. So for loop vector tree node iterator p is equal to temporary children dot. Okay, so we created some typing error here. It just had to be children dot begin and then the children dot end. Hopefully that would help it. And now let's run the code. Okay, so we have first error here in line 125, error expected at the end of 125. So a squiggly bracket at the line of 125. So why is it expecting over here? So let's just go back here and see that the main function is closed, but there's supposed to be some kind of additional. So I think this is like the while loop over here, but I forgot to add that last one, which I guess is the class. So let's see if this one is gonna work with the one which is on the top here. Yeah, there you go, it's working. So now let's go back here and run the code, and boom, we have it compiled successfully. Now let's just zoom in and run the code. So you're gonna see a tree structure. Here we have the D drive. Inside the D drive we have programming fundamentals, and inside the programming fundamentals we have a quiz and we have project, 2 subfolders, and then we have 2 additional childs which are belonging to the D, which is object-oriented programming and data structures and algorithms. Like I said before, that this structure, the way of representing is pre-ordered traversal. So we could add this a little more additional formatting to make some indents, to make a little more better structure. Here we'll have indent with programming fundamentals in same indents, and then we'll have additional indents for quiz and project. But that was it with this video. I just wanted to cover the general understanding for tree abstract data types. Thank you, and I will be seeing you guys in the next one. Peace out.